right? So as I already explained you the infiltration, the meaning of infiltration, then I have discussed the percolation. I have discussed the relation between infiltration and percolation, that these terms has to be uh, discussed. So now no question I have the infiltration capacity. Infiltration capacity, what does it mean, right? So again we need to understand this term. So the term has been already explained to you. It means maximum rate at which the soil is capable of absorbing water, right? And it is denoted by this small letter F. Fine. Uh, and you have nothing to worry when you get downloaded this slide. The things will be clear. But obviously next time I'll remove this wallpaper and get some more bright wallpaper there, right? So now that this infiltration capacity as I've already explained in the previous slide also there. What does it mean again? It means maximum rate at which the soil is capable of absorbing water, right? The rate at which the soil is capable of absorbing water there, and it is denoted by this small term F, right? And on the basis of this there are one mathematical relation has to be established here, where you can easily understand there is I is greater than equal to F, I is less than F, right? And here another thing that you are able to get there, FA, right? FA actual infiltration capacity, I is the rate of rainfall, and this is F is infiltration capacity. There is theta, right? Again I am saying FA, that is FA, let me write it here, FA, right? FA represents the actual, it means actual infiltration capacity, and I is amount, I is rate of rainfall, and F is infiltration capacity. F is infiltration capacity, right? So first we need to understand this term I is greater than equal to F. What does it mean? It means if the rate of rainfall is greater than or equal to infiltration capacity, right? So actual infiltration capacity should be equal to the infiltration capacity. It means, let me simplify you there. If there is more rainfall, by voice is clear now? Fine. So since I represent the rate of rainfall, it means the rate of rainfall means that amount of rainfall in a certain time frame, that is rate of rainfall. So uh, if there is a more rainfall in a short period of time, just understand this aspect. If we have a more rainfall in short span of time, right, and that amount of rainfall either equal to or greater than the infiltration capacity of soil. Infiltration capacity of soil, it means the amount of rainfall is more than the infiltration capacity. Then what will happen? Then actual infiltration capacity should be equal to the uh, infiltration capacity, right? And the thing should be reverse if it is the next condition you have that if I is less than F, it means the rate of rainfall is less than the infiltration capacity. So actual infiltration will be the amount of rainfall. You can easily understand that, because why we're talking about the rate of rainfall, because the rate of rainfall provides you the amount of water that need to be infiltrated, right? So if as per the infiltration capacity, if it is less than, so obviously that can be easily absorbed by the soil itself. So that will be the actual infiltration capacity should be equal to the rainfall. Despite actual is more, it may be more, there will be chances if the soil is more porous, right? It may, you just take this kind of example. If we have a sandy soil, just try to understand, right? If it is sandy soil, so what will happen? If any kind of rainfall will be, that can be easily um, absorbed, right? So if it will be more or less than, sorry, if it is equal to or more than the infiltration capacity, so obviously the whole amount can be there, whatever the amount of rainfall, And if it is less than, so how much amount has to be absorbed by the soil? So the amount that the rainfall has to be provided, amount I'm talking about, the amount of water that the rainfall has to be provided there, that has to be, only that amount of water has to be absorbed, right? It means here the amount of water is less, here the amount of water is more. Is it clear up to this point? The concept is clear to all of you? Any question up to this point? So now we need to understand the factor affecting the infiltration, what the factor is there. So that we need to understand there are certain factors that will slope of the land, degree of saturation, porosity, compactness, land use, temperature, other factor, right? So these are certain factors on which the infiltration has to depend upon. So uh, let me explain you everything one by one. So first, slope of the land. How the slope of the land has an impact of the infiltration capacity. So the steeper the slope, the less the infiltration. Right. Why this thing will be there? It means the more steep will be there, more steep, less infiltration. What's the reason for that? The reason is there. If water need to infiltrate, or the amount of water that need to be infiltrated, so they need certain time to infiltrate, and they also required, so that's why water needs some rest time. It means water has to stop at certain place for few hour or few minutes, whatever the time is required, and then the infiltration will start, right? But if there will be a slope, then what will water has to flow. Water are not supposed to stop anywhere, it is not supposed to deposit here itself for any place. So if there will be no rest period, or if there is no any arrangement whether water has to deposit itself, so there should be no infiltration at all. So the steeper the slope, less the infiltration. So if it will be more flat surface will be there, you'll get more infiltration there, right? Now degree of saturation, you can easily understand the again things, right? And let me give you one example. In the rainy season, after continuous rainy season of 5 or 6 or 7 days, you'll get one phenomena, that there is a uh, water on the surface of the soil. Water on the surface of the soil, it means after a few days of rainfall, there is no infiltration. The other way you can say that it means the soil get saturated, isn't it? It means all the pores, all the loose area, all these gaps has been already filled. So it means the whole area gets saturated. So if there is rainfall after that, so that should not be infiltrated there. So degree of saturation, or degree of saturation is the amount of moisture or the amount of water that is already available in the soil itself. That is also going to decide the infiltration there. If it is saturated, more saturated, so less infiltration will be there. Less saturated, more infiltration will takes place. Then porosity, right? You can easily look at the porosity, isn't it? Porosity means what? The open space, pore or cracks in the earth surface, isn't it? So we have just two example has been given there. Sponge there, lots of open space it has, isn't it? If you go with the clay brick, there is a very less open spaces there. So in which we have get more infiltration, obviously in the sponge. So the infiltration also depend upon the porosity, and simply meaning of the porosity you can easily understand that open space. It means the pores and the cracks in an earth surface. So if it will be more pores, more cracks, more open space will be there, more infiltration will takes place. So porosity is again one of the factor for infiltration. Then compaction, right? Compaction means how this soil grain has been packed itself, isn't it? That is compaction. So, and again go back to this soil science. You have already studied there. This clay surface soil are compacted, isn't it? Very compacted, this clay surface soil. So if there is any kind of compaction like that, so you will get very less or negligible uh, uh, infiltration you're supposed to face there. So basically this compaction is packing of soil grains, how this all soil grains has been arranged itself, right? So if it is clay surface, obviously less infiltration will be there. Where if it is a sandy soil, you will get more and more infiltration there. Then surface cover condition, this is very important, right? As I told you related to the slope. If on the slope and the slopy area is very dense forest or it is well vegetated, then you will get certain kind of infiltration there. So there is one example that you people are getting, those who are belongs to the hilly area, getting this spring, certain kind of spring to collect their water. So generally those hills have a spring where the hills have vegetation. If the hills is totally inundated, there will be no spring is available there, right? So surface cover condition is required because if vegetation will be there, so when water has to flow, so water the movement of water can be slowed down. It means water can stop itself at certain point, then the infiltration will start. So more the vegetation will be there, it is going to first it will start the infiltration process there itself. Is it clear? First thing. The second thing that we need to understand that this is a step. Slower infiltration means what, right? It means if vegetation will be there, obviously infiltration will start, but it is also going to slow. If more vegetation will be there, it is going to slow the infiltration. So how the infiltration can be slowed down? So because of the leaf litter or the branches that has to be fall on the ground. So if leaf will be there, so water has to flow on the leaf rather than moving towards the soil, because the soil surface is already covered with the leaf and the branches. So obviously infiltration will be less there. I hope now the term is clear. Oh, sorry, the concept is clear here. Now land use, this is the things that we all are witnessing there. If this kind of concrete jungle you are able to see that, it means the surface, the open surface is no longer permeable. It is only covered with the concrete. We have a roads, we have the pavement, that is cemented pavements we have there. So how the water has to infiltrate itself? So if you have to look at this aspect also, that land use also going to have an impact on uh, infiltration capacity, right? Now the temperature, you can easily understand that. Temperature means at high temperature viscosity decreases and infiltration increases, isn't it? So I hope most of you have already studied this term viscosity in your physics term. So anyone can say that what is viscosity? What do you understand by viscosity? Because we have just passed the 10 plus 2, so in physics we have studied this term. What do you mean by viscosity? So generally in the summer, the viscosity of water is going to decrease because of higher thickness of the liquid. So because of the high temperature, this thickness has to be decreased, isn't it? It means water has to get warm, so there is more space between the molecules. So obviously thickness has to be decreased. So if it will decrease, then infiltration will going to increase here. So that's why this summer infiltration will be more, winter infiltration will be less, right? And these are some other factors that is responsible for what I'm saying, that is responsible for this infiltration process also there. For example, entrapped air in pores. Again, if you study, go for the soil science, we have already studied that in a soil there is some pore space has been filled by the air particle also there, air is there, right? Air has been trapped there, so if air has to be there, it means porosity of soil may be less, so infiltration will be accordingly, isn't it? Then density of water is there, then freezing, and finally the annual and seasonal changes, right? So these are the some other factor is going to have an impact on infiltration process. And now this is the device that has to be used to measure the rate of infiltration into the soil, that is known as infiltrometer. This is the amount, this is the instrument that has to be used, and there is two such kind of instrument, is a single ring infiltrometer and double ring infiltrometer. So this is the instrument is there to measure the uh, rate of water infiltration, and generally this rate has to be measured in millimeter per hour or inches per hour. You get that? It has to measure in millimeter per hour or inches per hour, right? So through using this instrument, the infiltration process has to be measured, and this is the unit that has to be used here, right? So this is all about the infiltration. Now if any question from anyone, you people can ask.